My name is Dragan Jerosimović. I'm a game engine programmer at 3Lateral, which was recently acquired by Epic Games. These are some legal stuff that I have to show. This lecture will be about believable digital characters for interactive storytelling. I'll give you a bird's eye overview with some deep dives. I'll tell you something about the past, something about present, and mostly about the future. This will be a brief history and philosophy of the digital medium. I need to go through this with the focus of things important for interactive storytelling. This is an introduction to a set of hard problems awaiting storytellers of the future, and more about problems than solutions, and more about what's and whys than hows. Maybe for some another lecture will be more about hows. These are things that you maybe know, but from different viewpoints, which some very smart people say that is worth 80 IQ points. This is not a technical lecture. I'm sorry for the tag, because there was some misunderstanding with the organizers, but there will be some techniques. This is whom this lecture is for. And I'll ask you to just watch the screen. Don't you can take pictures, but you will lose you will lose a lot if you fiddle with the phone. So at the end, I will show some references that you'll see on the slides. This is my intention, maybe you'll think that some of these things that I'll say are necessary, but I really think that they're important. So this is the idea. Who am I? I'll skip to this part a bit. I'm making games. 10 years professionally. Before that, a lot before that, as a hobbyist. This is the biggest game I worked on. I did this was about organic spaceships, genetically engineered by human race, and it had a lot of things. It was done by a small team in Serbia, and it was published by Dreamcatcher. This is some technology that we did, like interactive cutscenes, and the programming language that was part of the tools. I'll get to this a bit later. There was multiplayer, and I did some special effects design. I did some mobile games for Telltale. I did some art for a game at Supersonic Parachute. There's some characters, some models, animations. This was about AI-empowered mouse, a lab rat that was trying to sort out things in a house of his scientist, where he was experimented on, and printing 3D weapons to solve that. I also did some designs. The game died, unfortunately. This is an indie game that we went to Independent Games Festival at GDC. This was whole procedurally generated with characters, animation of the characters, and music. You can see the demo on the link. It won't be shown later, sorry, but you can write me an email and I'll send you. This was a point-and-click adventure engine that I done by myself. I had a couple of friends helping me for like maybe 2 months, but it lasted for several years. I did some art also for that. I do other art. It's not game-related. I do underground comic books. This is a game that I wrote in elementary school when I was 13 years old on a ZX Spectrum 48K. I had trouble uploading this like from an audio tape that's decades old, but I managed to do it. This was the machine. This was one of the best machines ever made, because I was able to teach myself how to program without even knowing English, because it had commands on the keyboard, so you could just type in and commands would appear, so it was much easier than today. This was one of the games that inspired me. It was made in Croatia in 1985 by Suzisoft. This was also one of the inspirations. I'll get to this one later, because this is one of greatest adventures of all time, I think. These are some of my games for Atari ST, horror game with vampires. And this one introduced, this is a random world modulator, which was a device that when you press a button, it transports you to a random parallel universe. So leaving the part around you alone. It was, of course, not procedurally generated or anything. It was scripted totally, but it was a nice story. And I also inspired a friend of mine to start a company that turned out to be quite successful in Serbia and worldwide. 3Lateral, that's a company that does digital life. What that means is that we create digital characters as assets for interactive environments, faces mostly, but now bodies and creatures. We did some of the games that you know. We did some interactive, not interactive, but real-time demos. Some of them were interactive, so you can later check the links to see. So this was Andy Serkis. This was first time that we used our auto-rigging solution, so it was mostly automatic, only eyes and teeth were not. This is done this year on GDC. Our process is very complicated. It includes around 90 people, something more than 90 people. We do a lot. We do scanners. We do software for the scanners. We do all the processing pipeline and tools and real-time solutions for game engines, and now we're integrating that into Unreal Engine, some of that. We do scanners were first 3D, then now 4D, which means that they are doing 60 frames per second of full 3D scan for the actor performance. We do other stuff, rigging, hairstyling, and shaders. That's all part of the process. And we, of course, do magic. Like we tell computers to do stuff for us, and they do. This should be a video now, if I'm lucky, but probably not. So let's use the YouTube.
Out! Brief candle! Life's but a walking shadow. A poor player that struts and frets his hour upon the stage, and then is heard no more.
Just a minute. Okay. Please don't fail me again. Okay. So, digital characters. This is the topic. I hope this thing will go away. Please go away. So I need to talk about the digital first. I thought that first binary system was designed by Leibniz in the 17th century, but then my friend Chiming Wong here at Reboot corrected me and said it was I Ching. So after that, von Neumann did it with electrons, replacing these people with this stuff and enabling human race to do this, which is not a very nice start for an invention, but it got better later. This is first computer graphics, bitmap letters. This is a sketchpad from Ivan Sutherland. This is amazing stuff. You need to look for it. And the thing is, once you can do letters, you can do text, and then you can do other media. So it enables to do a lot of stuff. So very smart people started to think, what can we do with this stuff, which media? So there was a lot of that done early on. At that time, approximately, some other people started to think about what are the adverse effects of media, and this is very important. So read this book. The thing is that humans don't understand media. Once we invent a new medium, it takes around 50 to 150 years for us to understand it. For that time, it completely changed us. For example, printing press, when they made it, they didn't. It took them almost a century to understand that they can print another book, some other book, and that this started the Industrial Revolution. And because we don't understand them, we we emulate the old media in the new ones. So we, each one, this is McLuhan's idea that each new medium contains all the previous ones. So, so it was discovered that a computer is also a medium. It's not just a machine that can do media, it's a medium itself. And the thing was what kind of medium it is. So it's a medium that can do dynamics, it does calculation, but it can do calculation in time. But because it can do this very fast, you can simulate things that you cannot calculate on paper. So this is first gravity simulation. And it actually turned out to be a simulation machine. So the question was, what can it simulate? So this is Alan Turing, who did some formulas that much later turned out to be true, that they produce patterns on animal skins and cells. This was von Neumann trying to make a self-replicating machine as a mathematical concept, and his colleague also did some experiments in artificial evolution. This is why I mentioned them, because they were doing digital life in 1953. And much later, Carl Sims applied a similar idea to mathematical functions. So he was randomly combining functions and got very natural looking motions for creatures of random morphologies. He was randomizing the body shapes and putting physics on them and motors, and then simulating the stuff and just measuring how far they are from the goal, and they learn to walk, swim and stuff. You can also simulate molecules, you can simulate the brain. This was done last year in November, like the first electronic brain. This is around 1 million neurons. Human brain has much more. And if you're game designers or in any way related to games, this is the lecture that you must see, because this analyzes in very great detail of what this medium, the specifics of this. You probably have seen it already. So the thing is, the next question, what it cannot simulate, and we don't know that yet, because everything that was tried, it was successful, almost. This is from Matrix. But the book that Neo is holding in his hand is from Jean Baudrillard, and this is a very important book for us in this medium. And in 70s, they tried to experiment with this and come to some very interesting conclusions, like simple rules can give you complex behaviors, simple formulas can give you very organic and very complex forms. Then much later, Stephen Wolfram did some experiment exploring exactly what do you need to get this kind of complexity. What's a minimal system to do this? And it turned out that the minimal system is very minimal. It needs just 2 states, so it's a binary system, and you need 3 rules, and that gives you universal complexity, which means that it never repeats, it creates new information, it's not predictable, but it's still deterministic, which some people don't get. And it's irreducible to elements. It's pointless to analyze the outcome of the system, because you need the whole history is what created it. You can simulate anything that the universe can produce. This is what the term means. But you need to unfold the entire history to see the outcome, so you cannot know the outcome in advance. You cannot predict it in any way. It also, Dave Snowden pointed out that also complex systems can have simple behaviors, which is very interesting, like societies or biological systems, because they have phases, like you can switch a system from a phase to a phase. One of other characteristics of the medium is interactivity. You all know that, you're game developers. But people didn't know that at the beginning, so it was about speed of computers, and you can also simulate time. This is the first game I ever seen that had undo function, like you could go back and then that gives you safe exploration. There's no frustration about like making a wrong move. You can do it. So then in education, I will skip education because nobody cares about education. So they had. This is what computer literacy meant in 70s, and it didn't happen simply. like writing dynamic models. This was the idea, this is what computers were made for, and it's forgotten now. We do other stuff with that, we'll watch YouTube and whatnot. So this was a system made for kids to learn programming, and they were very successful in this. This was later rebooted in One Laptop Per Child project, but and also they shown in India that you don't need teachers. You can just give computer to kids without any instructions. They will learn English to learn. I did this when I was a kid. This research in certain form is continued on Human Advanced Research Center, but it all was forgotten at the moment, like when somebody came to the idea to hack the radar screen and make a game. Then after that, all education thing was forgotten, and we start play games. So, me too. The thing was the evolution of graphics. It went from very rudimentary ones and evolved. And this is Ken Perlin in 1995, doing very, very realistic and very believable characters, procedurally driven. But this was because this worked because this was stylized, and it worked for some times. We all loved this character, although she doesn't actually look realistic or anything, but we didn't mind because it was amazing to have this kind of environment and a character in it. And the problem came when we started, the computers became fast enough to do realism, then everything that is missing, like your expectations, if the model is realistic, your expectations are also to that animation will be, and this turned out to be a big problem. So I won't show any slides not to offend anybody, but you all know which films have done computer graphics that were a bit of uncanny. So at first people thought this is impossible to solve, but it is possible to solve. You just need much better models, much better rigs, and this is very hard. So at 3Lateral this was done manually for almost a decade, more than a decade. You need hundreds of blend shapes, you need a lot of human expertise, and so this is why companies come to us, because very often it turns out that they don't know how to do it well. The other idea was machine learning, but machines don't get semantics, but actually you can make them in a certain way understand semantics. So we combined human expertise with machine learning. This is our secret sauce, like do the both things. So can we cross Uncanny Valley? I think yes, it will happen very soon, and this talk is not about this. I want to talk about what's coming next. So this is the Uncanny Valley 2. Actually, you will have very realistic characters, but the problem is that expectations of the audience will also rise, and behavior won't match the looks. So this is a kind of a joke prophecy. A great mismatch will fall upon the world of games. Everyone will look good and move smoothly in high resolution, with their faces showing great expressiveness. Their souls will be empty, their thoughts shallow, their words without substance, and their actions not as meaningful as the audience expects. So we can maybe, this is questionable, because we already have a very realistic characters, and we all play those games, we love them, so what's the problem? And we can also lower audience expectations. This is what many companies are good at, but especially mobile ones. But this will be the challenge, and we might avoid for some times, but we will come to the point where we need to solve this. So unfortunately, this will be up to game developers, because I'll explain later why. And to see this problem from depth, we need to go all the way to what the character is. So this is dictionary. It has to do with moral quantities, distinctive, interesting, strength, and good reputation. So this all goes around morality and ethics. In the media, like the other meaning of the word, it's connected to storytelling, acting, and also person, but like the various aspects of person. But now in this, our medium, which I won't name yet, we have this all changed, because when you put the player in, then all these terms get some other meanings. So, and they all make sense in that world. So, like, player now becomes the character, the person, actor, and the author. It can replace all of these things. And it's also the audience, yeah. And this is something new. I mean, when I say new, I mean compared to the old media, so it's new. So we need to examine, because it was related to storytelling, what storytelling means in the new medium. Why am I saying medium, not a game? This Amy Henning told today on her lecture that not necessarily it needs to be a game. All interactive experiences, all games are interactive experiences, but not all interactive experiences are games. So games have goals. You can achieve goals or fail at them. You can aim for them. You can get better and also try again and try again. This is what animals do too. This cute cat will actually kill a mouse someday. So she's training for real life, and it's actually learning to make better choice in movement. And this is something that games are in their core, but storytelling doesn't need to limit itself. So this is, for me, the best book ever made about games. It's not about computer games, and I advise you to read it. And the reason why I'm using the word medium is because I think that games are maybe one star in this universe that we have not explored yet, because we don't understand media. Also, I think this is a Hindu saying, I'm not sure. So, you all know this. What interactivity brings to storytelling? Brings a choice, branches the story. The first, you had your choose your own adventure books, but this were not the first one. The first one was made in 1930. And this is changing what the meaning of storytelling, actually. Because in old media, the author told a story to the audience, and in new media, participants, let's call them that, they do a lot of stuff that the author did before. So maybe they are co-authors or something. And this confuses all the authors because they are used to telling stories to their audiences. So they are... And of course, what's storytelling? So in days of old, it was about information transfer. The author sends a message and changes the receiver. This Claude Shannon, you won't find this at Claude Shannon's work. He wrote about communication, but this is what it does. It changes the receiver. So what was the reason for the authors to do this? Like, okay, stories, people love them, empathize with characters, they live through their destinies, but characters was actually about choices one makes in real life and goals that he chooses. So characters were examples of what authors thought people should try to or avoid to become. And so this was the means to change their audiences, actually. That was the intent. And why? Because that was the best available technology at the time to keep record of what's good and what's not good. And societies live and die depending on this. There's a great book by Joseph Campbell. You know him probably for A Hero's Journey, but this one for me is maybe even better. It's about myths around the world. Yeah, so we need to also tell it through a medium. Not always, but before stories were told in words, but we started to use media, and Marsha McLuhan again says medium is the message. There's no passing the message to the medium itself is a message, and he got a typographic error when his book was printed, so he got massage instead of message, and he liked it. And he said, okay, this is totally in line with what I'm saying. So both sender and the receiver get a massage from the medium, and they're both reshaped. So we as authors, what do we aim to reshape our audiences into? This is the important questions. Because even if you're not, you're reshaping them anyway. So let's say that we are benevolent, and how do we do it best? And knowing that the medium is interactive. So we need first to think about how it's different and how it's the same, and is there anything useful from the old media? So how it's different? You know all this. So this is the old stories, like linear, not exactly linear. They wind, but they get to the point B. With choices, you have branching, and so the structures that we are making, it's not a story, it's actually a story tree, a tree of stories. So one of the ways that to solve this was, for example, LucasArts games, not of all of them. I'm not saying that this is wrong. I enjoyed all of their games. So this is just one way to write a linear story and put the obstacles on it. So let the player solve the puzzles. But should it be about the puzzles? That's the question. Also, you can be a very brave writer and start to write it down. I did it when I was in high school. Like, okay, I'm going to write all the stories down. So, but the creature you're fighting is a Hydra. You cut off one head, two others go, and because this is exponential, it will go to billions very soon. So you can't do this actually. So you can trim the tree down and say, okay, this is it, but this is again like on bonsai trees, it's too small. And you can put the lines back together to make it down, but this is fake because your audience knows that it's fake. They expect the story to branch. They expect many outcomes, and when they get the same one, they will not be very happy about it. And you can make labyrinths out of it, but it's still static. So all these types here assume pre-written static stories, and our medium is dynamic. So somebody will ask, so what? Nothing. But there are certain applications where you need your story to be dynamic, and the last one, like stories about players' character. I don't mean player character, but players' real-life character. There was a game in 1986 by LucasArts which observed what you did. He says there, we have been watching you, and he knows what you did before, so it can be used as a medium for player behavior correction. That means ethics amplifiers. And also, if you want it to be an art form, there's a unity of form and content required. So you cannot use one form and have a content of another medium. So, like we're in the 21st century now, the medium is dynamic, it's virtual, it can simulate anything, it can grow information because it creates new information and it grows. So, can it grow story tree? If it has universal complexity, it can make an entire world, like No Man's Sky or similar games. So why not a tree? So we have interactive storytelling, which we need to correct because we are writing them now, not telling them, and it's not a story anymore, but it's a story world. So we build story worlds, and this is a thing that like man is a tool builder. Man is not just a tool builder, man is much more, so he's the inventor of universes. So let's see about interactive story worlds. You all know Dwarf Fortress. We're going to go through. What are they? Well, places for growing story trees. Because they're complex, they are dynamic, they're immersive, and they are interactive. Virtual system, what does virtual means? It's something that is ideal but is nonetheless real. And it's a system. So you'll need all these things to make a system, and don't be scared, this is actually very fun stuff. Virtual systems representing worlds in which stories happen, and this is also different from the old media because stories were imagined by the authors and told through a medium, and now they're really happening in the medium. Like you are constructing a set of systemic rules, and these rules, even if they're totally fictional, they are real inside that world. You cannot break the rules unless the game designer allows you to, but then that's also a rule that you're using. So it's everything that is happening in the medium is happening in the medium, and it's executed once the world is started. what we get out of it is interpretation. Our interpretation, and there's a lot of debate like how this should be done. But it doesn't have to be story also, it can be just an experience, but there's many good things developed through centuries about stories, so we should use all that. The thing is, because this complex system, the outcomes are not predictable even by the authors, so this is one of the problems that we have. And what they are not? Well, all other simulation or world simulation, they don't tell stories about unique characters. So they generate stories about characters in the world, immerse them into that world, provide them with choices relevant to the story, but there's no story anymore, so characters' destinies. Let them suffer the consequences, the characters, not the players. We, the participant, can think about them, try again, and undo maybe their choices, means explore the story tree, and then learn the rules of the world they inhabit, so they can help characters achieve their goals. So it's because storytelling is usually about characters achieving their goals or not achieving their goals, so this is here, but not in the same form. What do they get that cannot get from the old media? Well, storytelling is reductive, which means that it reduces the complexity of real world into a story. This is writer's job. Writers are very good at this, and I don't think that we very soon come to the point that we have story worlds that are as rich as writers can make them, but it seems that everything is going to that direction. So it's storytelling is something like a map. Map reduces the complexity of the world, and story worlds are different. They are inherently complex, which means they're irreducible. And system dynamics make consequences propagate. You affect these consequences. Everything affects everything else. History matters. Each choice determines the entire future history of the world, therefore the destinies of all the characters. So the different thing is there's an ever-present unity emerging from this of events in space-time, just like in the real world. So this is like in stories, we try to reduce the world to important stuff so we can show this, usually. And in story worlds, it's already there inherently. Also, we have this totality of wider picture in old media indirectly, and here you can see it, tinker with it, and get deeper understanding of the rules that create it. And there's one important thing, simulation is not the real world, never. So understanding cannot be of the real world, but of the rules of the virtual world. This means that this is only a system of science, actually, that points to things in real world. So there's a problem with this, and Baudrillard wrote about this. The problem is called simulacrum, and simulacra is a plural and means the copy that depicts things that either had no original or no longer has an original. So it's a false thing. In programmer terms, this is a null pointer. It doesn't point to anything. And these are the stages that Baudrillard explained. Like, first you have a fateful image, then you have a perversion of reality, then you have the thing masking, the symbol masking the absence of profound reality, and then you have a pure simulacrum that doesn't have anything to do with anything. So we know this, and we know now that this is a science system. So now that we are aware of that, we won't get into any dangers, so we can think about what real world truths do we as authors point to. If we don't, we are just making a simulacrum. And there were too many already in 1981 when Baudrillard wrote his book. So he was very disturbed by this, and he should be. So now we have another problem that our systems now are not, the symbols of the past were reduced, and now our symbols resemble reality. So it can become more important than reality, and people die in virtual worlds, you already know that. This is the book. When I read, I couldn't sleep that night. It's about television, but it applies very much to games. And So we should better start thinking how to prevent this, and because it could happen to humanity, we are more deeply in games. So the processes simulated should point to real processes, so they are actually metaphors of real-world dynamics. Now, we need to consciously do this reduction, but on the level of processes, not story or something. So, what can we use from the old media? Mostly everything. It needs to be adapted in certain ways, but all the things that work in drama will work here. Also from film. Cuts, for example, are one thing that is not so much used. It should be. We let players roam the world and then spend their real life time in virtual worlds, which is totally pointless. And they don't play these games because they need to spend so much time. They just look them on YouTube. And the thing is that you need to express them as simulation rules. So we have a problem here. Writers are not programmers, and the programmers are not writers. The first one is easy to fix, the other one is hard. Because these are different cultures, and programmers train themselves in different kinds of thinking. They usually lack the skills of the writers. Writers are empathic and they think about people, and programmers don't think always about people. I'm not accusing anyone, but I realize that programming does this to me. So we need better tools. This is from Genesis Rising Tools, a programming language that we made. And one of the things that you might not see on this screen is that this here is actually an English-like sentence that transcribes what the program actually does, and you can click in all the parts using the functions on the side without having to do. And it's very easy to read. And we built this so our game designer could use this, and he's not a programmer. How do we do this? Now this is the hard part. No more pictures. We of course to model humans and characters, we need to model human behavior. This is hard. We need an executable model. So is this artificial intelligence? Yes, but we need to make some distinctions, like practical definition. Is ability of an agent to fulfill a goal in an unknown environment. This is by DeepMind people. They use this as their goal to achieve this, and they're using games to actually train these systems. And so something is going from games to general AI, and then goes from general AI back to the game. So this is Ubisoft's system for moving characters. It's amazing. But we need to make a distinction that the game AI is much less than general AI, so we shouldn't even try to do this because we don't have the hardware, we don't have the resources. Maybe it will happen organically in some way, but we need to be aware that we are very far from general AI for using games, unless reality surprises me. So we need to narrow the definition, and we need to search for a minimal definition. So an agent, autonomous virtual agents. Agent is a person that takes active role or produces specified effect. And interactive agents, because we don't need them to be totally autonomous, we need them to be interactive. That means interacting with the player and interacting with each other. And with a specific purpose for portraying characters in story worlds. So they need to stay in character, express their emotions, states, thoughts, and plans. They need to be able to make plans. So the participants, by experiencing the story world, reveal profound truths about the human condition in the real world, and maybe even learn something about themselves. I think this is possible. The rules of the world that we make need to model all of the above if we want this. Good thing is that all these things, which are basis for the characters in old media and in real life, are actually can be modeled by goals, and agents should be able to select these goals. But they need to make meaningful choices, otherwise they will not be very believable. So what does it mean? That means that you need to make a plan for the future, plan which is sequence of action choices to accomplish a goal. but because your actions affect the world, everything is interconnected, everything that you do transforms the world forever, so when you execute your plan, the world is different, so your plan is obsolete. So you need to update the plan all the time to predict actually what will happen in the future, and to be able to do that, you need imagination. Imagination, so you need a mental model of the thing you're predicting. So mind, actually function of mind is to do this, to virtualize real things, and imagination is using these mental models to simulate their behavior in time and predict their future states. So this is hard in biology. Evolution took billions of years to accomplish this, but in virtual worlds we can simply, because everything is virtual, we can simply copy the world or part of the world. That's important because the worlds are usually huge. And simulate consequences, so the agent is looking into the future and see what happens. You basically run an instance of a game and see how it will go depending on each choice. So here we have a unity of form and content because search trees are equivalent to story trees. What we do with our minds is equivalent to what we try to tell with our interactive stories. And agent can score the future states, imagines the choices, measure how far is it from the wanted goals, and then actually do the one in the present moment so it will turn out to be useful in the future. All AIs do this in some way, and all people do, and also cats. So, but to have believable characters, we also need because most of AIs in games are just like about movement, but we need human beings have models of other human beings, and they try to predict their thoughts. So you need to have characters simulate other characters which simulate you, because I know what you know that I know, so you know. And actually, this is not science fiction. This is already being researched and done and used in training the soldiers. So it's 2009. And it's not that complicated because it's like a chess game. You just imagine what your opponent will do, but you score inversely. Like for your opponent's move, you put a negative value. For your own, you put positive values. And this was done before computer games existed. It was done on those computers that Neumann made. But the problem here is exponential nature of that story trees. So, but there are ways. Like first time they tried in 51, they didn't manage, but then in 58 they did. So we are getting more powerful hardware, better techniques, maybe quantum computers. They are announced. So we will get there. I can't tell you when, but the problem is that our present computers are not very powerful. I mean, they are in some terms, but for this, they're not powerful enough. So what can we use? We can use those techniques from the old games. They had ridiculously slow machines. They couldn't do anything, but they did stories with dynamic worlds with characters. For example, in Hobbit, characters walked around, they picked up things and did stuff. You could even tell a character to do something for you, like put me on the shoulders and then go to the window and climb the window because and tell him to go somewhere. So it's about reducing because audience is using suspension of disbelief. They want to believe. So when we played these games, we were totally immersed. We had no problems with that. Characters' behaviors were totally random, but it worked for us. This is also another Spectrum game from '97 by a man called Mike Singleton, and look at those verbs. Now, the problem is like the more actions you simulate, the more choices you have, so the bigger the story tree becomes. But one thing I want you to think about is why don't we have more games which has this amount of verbs and this type of verbs, because everything of this is inter-character relationships. Where are the games with that? Also, you can use techniques from engineering. So you have amazing online courses by Sebastian Tran and Peter Norvig and guys who made Google Self-Driving Car. And they're explaining actually these things in very great detail and formula. So if you're a programmer, you can just go there and look at that, and this is really useful. Because I was amazed, Sebastian shown on a course, like opened the trunk of the car and shown that it was all calculated on a 4 quad-core Pentium. And I was like, what? A machine that you can buy in a store. So there's other techniques like saliency, generalization. Saliency means that you don't simulate, of course, the whole world, but you cut off one part that's important for the moment, the prominent features. You simulate them. You will make wrong prediction, but we are making wrong prediction in life all the time, so it's not a very big problem, because like if character does something wrong, that could be a good for a story. Like you know that what he tried to do and then he failed, so you have a drama. It's a good. Also generalization, so instead of simulating, I don't know, 10,000 characters, you put them as one group and simulate that group, so you can layer your world into, you can cut your world into layers and make interactions between layers. And each one can simulate a higher order, so it's like instead of 10,000 entities, you can simulate 3 entities. And just, you know, like this army, this is what these figures on the strategic maps do, so we can do that too. You can memorize things that went well, and using generalization, you can put them in another context and then trigger them, so you don't have to calculate all in advance. We have this in our bodies and brains, so why not use it for the characters? You can use randomness. When your search is stuck, you can just do something random and try again. Actually, this works very well. Monte Carlo tree search, which is used in some games for artificial intelligence, for strategic artificial intelligence, is using this algorithm, like do random stuff and then try to like continue doing stuff that brought you to results and cut off the stuff that's not. So it's also the genetic algorithms that all can be used for this. So what are minimum requirements? In my opinion, like without this, we won't have very believable characters. So you as game developers should start, this is not happening tomorrow, but in the course of like 5 or 10 years, there will be more and more games modeling this. There already are, even mainstream games, like it's not something obscure. And you just try to make a most simple model of these things that you can think of, engage a writer, engage a psychologist, talk to them, and then make a simplification of that, and then run a simulation, see how it behaves, and then improve it, and you will get there in time. The thing is, also we can use this, like about complex systems, there's amazing work by V. Hart and Nikki Case that's using very simple characters, but showing like very important behaviors of societies, of people, using very simple rules. And these rules work in real life. So this is mimicking the real world processes. Like this is a metaphor, this is interactive metaphor for a real world thing where people move out from one neighborhood to the other depending on their racial preferences and so it's a political thing, but it's also like, not political, but sociological thing. Also, you can read psychologists. I recommend Jung over Freud because Freud was reductionist and Jung was not. He actually introduced the term complex into psychology and he thought it was a building block of psyche. So the good thing is whatever you do, all the models that you do, you can transfer to next game and to next game, just improve them over games. So you don't lose time actually, like you're losing time when you're making graphics engines because hardware changes. This won't change. So without this also it would be very pitiful if we don't have this as in our models because like humanity deserves it. Like this can be forgotten. If people play games all the time, they're not training themselves into things that are useful in the real world most of the time. So it's important that we encode the best things that we have into rules of our simulation so they actually can transfer that back to real life. You're teaching children how to live through your games. And Because this is ongoing research, these are open problems. Top-down, this is what game developers do already for years, and they are first at academia, then it's going to game development. Start simple, do experiments, generalize. And then when you do generalization, then redo the specific stuff with the general things, and you'll get reusability, and this is what we use at 3Lateral for our models of the face. So, for example, this is a first interactive drama ever made. It's not graphically very good, but actually they model the inner states of the character, their relationships. This prom week also by the Michael Mateas on University of Santa Cruz. He was doing this stuff, and then his students did this. Also amazing work by Richard Evans and Emily Short on Versu. You can go to their website and read the material that they posted about it, their thinking, and also the solutions that they have. It's really good. It's not commercial. It wasn't a commercial success, but people forget that many of the things that were created through history and that later become commercial successes didn't at the beginning just because people didn't recognize them. Also, Emily Short is working on the tools for authors, for writers to make this thing easier, because it was very hard. I spoke to her at GDC, and she said like the biggest problem was modeling these social interactions, so she's not trying to solve this. Also, there's another line in different directions, like going from bottom up and modeling like sensory motor interactions, and this will probably solve it at a point, but because you need the hardware, only researchers at big companies and universities can do this. And these are some of the examples of the agents that are not characters but can be used in storytelling. And you have examples of this already in, I think, Far Cry 4 used the AI director, and Left 4 Dead. And so you can, just like your characters are planning what they should do, you can have an entity that's calculating all the other entities and trying to find something that will be either pleasing to you or scary to you or something. So it's going through to the choices of the characters, simulating the world, and then getting the You can also give them special abilities like make a new character or blow this town or away or something. So it can create a drama to make it more interesting. Because the problem is with story worlds, you don't, as author, you don't know how it will end. So, but you can use AI to predict and then pick up the interesting things, and also to maybe try to extract these AI curators that try to extract interesting stories. Because to simulate whole world in so many different choices, that's computationally expensive, but you can do it once and then pick up the interesting stuff and then build from that. And the reason why I'm telling all this, because when personal computers started, the idea was to teach kids to think much better than the adults. And Alan Kay, who was part of that, said that their problem, what they didn't count in, is that humans need spectacle. Humans don't get, not many humans get into something that's hard and then spend years studying it. So we can use these systems with believable characters to inspire people to try to actually learn something about the real world, because real world is a dynamic system, and it's complex and it's falling apart. So we can help future generations by making story worlds for them that will teach them about the things. So maybe once the idea of personal computing will come true, how it was envisioned at the beginning. And if you want to talk to me about these topics or any other, you can contact me here. And these are, if you want to take references for the slides, and if any questions, there should be a mic somewhere. And do we have time? Yeah. And we are hiring, yeah. So, so if you're a C++ programmer or Unreal especially programmer or a researcher in mathematics, and you can call us. Yeah. These are the education slides, if you want to take. And so the questions.
Yeah.
Sorry.
Questions?
No
Everyone's
questions.
in a hurry.
Okay.
Let's thank the speaker one more time.
Thank you.